Look at this. I just ran a container and I typed who am I. It says root. That means this container has full power over its file system. It can bind to any port, and if it somehow escapes, it could affect the host system. In this episode, we will see why running as root is dangerous, how to run containers as non-root, and debug a real permission issue that happens in production. If you are new here, hit subscribe right now. Every week, we simulate real DevOps mistakes so you can debug them like a pro. Let me draw two boxes. One box is a default container, and the second one is a non-root container. It has a root user, it has a particular user. If an attacker escapes from this container, it can access our host PC. In this, it's like a restricted user, so it cannot do anything. So containers don't magically remove root risk. By default, processes run as root. If an attacker escapes the container through a kernel exploit or a misconfigured mount like var run/docker.sock, they can easily become root on our host PC because containers are directly running on our host PC, not in a virtual machine. Best practice, always run as a dedicated user inside the container with only the permissions they need. Let's jump into the demo. Let's try to run this container and get into that container. So for that, I'm using Docker run and the Flask -non-secure bash. Press enter. So right now I'm inside this container. I will write who am I. So you can clearly see that I'm a root user. So in this user, I'm going to create a file, touch /root secret.txt. Press enter. Now let's go to that location and see if the file got created. ls, you can clearly see that secret.txt is here. Also, let's try to update some packages here. Sudo apt-get update, press enter. Inside this container, I am root. I can update packages, create files in /root, basically do anything. In production, that's dangerous because if I escape the container, I'd still be root on the host machine. Now let me exit from this. So this is our episode 8 folder. I have different files: application.py, Dockerfile, Dockerfile v2, v3, requirements.txt. Now let's jump into our Dockerfile. So this is the same exact Docker file from our previous episodes. If you are following along, you should be familiar with this particular Docker file which I am showing right now. I am trying to create application user. I am running this command run user-add -m application user, followed by, after copying all the directories, I am trying to tell user application user. So I'm telling it should run as application user. Now let's try to build this. Now let's try to build our Docker file. So docker build flask -secure :v1, press enter. Our Docker image got built successfully. Once again, we are going to run the Flask secure container. Previously it was non-secure, now secure one. Bash, press enter. Right now I'm into the container. If I write who am I, You see application user. Now let's try to create a file in root location. Touch /root slash secret dot text. Press enter. Permission denied because we are running as application user. And also let's try to do apt-get update. Press enter. It says could not lock, permission denied. You see the difference now between the root user and application user? That's how it is. Now let me exit from this. Now let's look at the version 2 Dockerfile. Here we are trying to add user and also use that particular user. Instead of exposing 5000 port, we are exposing port 80. And in my application code as well, I changed it to port 80. Let's try to build this and see what will happen. I'm using the docker build command, Flask secure version 2, Dockerfile v2. Dockerfile v2. Press enter. Once this is built, we are going to run this using our port 8080. Docker gives containers some extra kernel permissions called capabilities. One of them is netbind service, which allows this to work. In hardened production environments, those capabilities are usually dropped, and that's when you will suddenly hit permission denied errors after switching to non-root user. The safer and more portable fix is simple. Don't use privileged ports at all. Change your application to run on a higher port like 8080. For example, here instead of 80, I'm going to use 8080. And in my Docker file as well, I'm going to expose it as 8080. Okay. Let me try to build this real quick. So I'm using docker build command once again, Flask secure version 3, followed by here this would be version 3. Press enter. Now let's try to run our container once again using port 8080, Flask secure version 3. Press enter. So if you see, it is perfectly running on our port 8080. Let's do a quick recap of what we learned today. Don't run as root inside Docker containers. By default, Docker runs as root, and we saw why that's a risk. Always create a dedicated application user. Use non-privileged ports like 8080 or 5000. Drop Linux capabilities unless you explicitly need them. And scan your containers with tools like Docker Bench for security issues. In the next episode, we'll integrate Docker into a CI/CD pipeline with Jenkins or GitHub and simulate a broken deployment caused by a wrong image tag. If you found this video helpful, hit like, share and subscribe so you don't miss the next video. Thank you for watching and see you in the next video.